All right, everyone, it's another day of Advent of Code 2015. Today we're working on puzzle 14. 14. All right, here we go. We're past the halfway point. We're reaching the top of the tree. Day 14, Reindeer Olympics. This year is the Reindeer Olympics. Reindeer can fly at high speeds, but rest occasionally to recover their energy. Santa would like to know which of his reindeer is fastest, and so he has them race. Reindeer can only be flying, always at their top speed, or resting, not moving at all, and always spend whole seconds in either state. Okay, that's going to be nice and easy. For example, suppose you have the following reindeer. Comet can fly 14 kilometers per second for 10 seconds, but then must rest for 127 seconds. Dancer can fly 16 kilometers per second for 11 seconds, but then must rest for 162 seconds. After 1 second, Comet has gone 14 kilometers, while Dancer has gone 16 kilometers. After 10 seconds, Comet has gone blah, blah, blah. We continue to rest until the 138th second when Comet flies for another 10 seconds. On this 174th second, Dancer flies for another 11 seconds. In this example, after the 1000th second, both reindeer are resting and Comet is in the lead at 1,120 kilometers. Poor Dancer has only gotten 1,056 kilometers by that point. So in this situation, Comet would win if the race had ended at 1,000 seconds. Given the descriptions of each of the reindeer, your puzzle input, after exactly 2,503 seconds, what distance has the winning reindeer traveled? Okay, so we're going to have, let's see what the puzzle input looks like. Okay, so we have a reindeer name can fly, a speed, kilometers per second. Everyone flies kilometers per second, but different speeds, for number of seconds. Seconds, but then must rest for 132 seconds, plural. Okay, so good. So now we just have to write a regular expression to parse this out. So here we go. We're going to do a reindeer struct reindeer speed, and var is going to be reindeer name. Might not be necessary as a matter of fact, but let's just include it anyway. Var speed, and string. Stamina. I'm going to call this stamina, which is the number of seconds. I'm going to say stamina seconds, which is the number of seconds that they can fly. So speed is, again, we have stamina seconds as an integer. Actually, this is not a string. This is an integer. Okay. Var, stamina seconds. Okay, and then we have, but then must rest for 132 seconds. I'm going to say rest seconds. Okay, in it, I'm going to do a descriptor, and the descriptor is going to be the string input. It's going to be one line of text. So in order to do that, we're going to need to open debugx, debugx.com, and I'm going to take one of these Dancer Comet here. So this is one example of puzzle input. Let's use this. Comet can fly, so we're going to say we need a capturing group, and that's going to be \w plus space can fly, and we're going to have, this is going to be stamina, so this is /d plus space kilometers per second for, and then we have another \d plus seconds, but then must rest for another \d plus seconds, period. That's all the variables I need to extract out of that line, right? The reindeer name, the stamina, no, the speed, the stamina, and then the resting seconds. Okay. Good. So we can copy this. And we're going to do let parser equals regex parse. And right there, we're going to have to double escape those. Oops. Okay, good. So we got Comet can fly for 10. Okay, so then we're going to do parser let groups equals parser on the descriptor, because parser is going to be a function. Regex parse returns a function. And then we can call that function on the descriptor. Okay, so then we have groups. The first group is going to be the reindeer name. So self reindeer name equals groups 0. Actually, this has to be a, like that. Yeah, okay. Self.speed equals integer groups 1 self dot stamina seconds equals int groups 2. Self dot rest seconds equals integer groups 3. Okay, I think that is everything. And these I need to be unsafely unwrapped. Okay, so given the reindeer speed, now we need to, I'm going to create a class. I'm going to say reindeer. And reindeer's going to have a name. And they're going to have string. And they're going to have, ooh, actually, I wonder if reindeer, this maybe should not be in this struct. I'm going to leave it in. This is going to be, I'm just going to leave it in because this is a very pure way of parsing the input. And I think that's probably going to be stable. I don't think I'm going to have to touch that with the next step. But I'm probably going to have to change this reindeer class a little bit in some way. Okay, so the class reindeer, var name string. Okay, so and then we have the var speed is going to be a reindeer speed. Ooh, better idea. So this is going to be return speed dot reindeer name. So instead of having to actually store that in the class, I'm just going to, alias it. I'm going to return the reindeer name from the reindeer speed instead. That'll make it nice and easy. So we're going to do stamina seconds. Oh no, so we have the speed. So now what we need to know is where, so let me put it this way. We can probably compute how far the reindeer has gone in a certain number of seconds. So if the input is a certain number of seconds, then we can compute precisely how far they would go in that amount of time. So let's say func distance traveled in seconds. And that's going to return a number of kilometers. And so we will start with, so how does this work? A comet can fly, but then must rest for 127 seconds. Okay, so after 1 second, comet has gone 14. So they start flying. And then they fly for as long as they can in that amount of time, and then switch to resting. So I wonder if there is how would I do this? So I would start with if while true. Let's do this. So we're going to loop forever until we determine that we're done. So we're going to say var seconds remaining equals int, and it equals seconds. So that seconds remaining, we're going to subtract from that over time. So we have, so we're going to let time flying equals, we're going to do the minimum, is it math.min? Is it just min? Yeah, min of the speed dot stamina seconds, or seconds remaining. So whichever one of those is smaller. If they can run for less time than is remaining, then that's going to be the amount of time that they're flying. So then we're going to go distance traveled equals time flying. Oh, let's do this. Our cumulative distance traveled. Cumulative distance equals 0. That's going to be an integer, and it's going to distance traveled. Actually, no, let's do this. Self dot cumulative. No, it's not even a self. It's this cumulative distance plus equals time flying times speed dot speed, right? So this is a little bit confusing because speed here refers to reindeer speed, but then within reindeer speed, we actually have kilometers per hour. Okay. Actually, this should maybe be called pace instead of speed. Let's do that. I'm going to refactor this. I'm going to say refactor, rename. I'm going to rename this variable to pace, P-A-C-E. There we go, pace. Okay, and now, so they've flown, and then we do seconds remaining minus equals time flying. And we're going to do let time resting equals min pace dot rest seconds, or seconds remaining. And then we do, so now he's resting, resting. Do seconds remaining minus equals time resting. And then if seconds remaining is less than or equal to 0, it should not be less than 0, but we'll just protect ourselves here in case there's a mistake. If time is less than or equal to 0, we're going to return cumulative distance. Okay. So from that, we can say so we're going to do let paces equals input dot lines dot map reindeer speed. So we're going to map this to a reindeer speed, and we're going to initialize. So each one of these lines is going to be converted into a reindeer speed. And then from that, we're going to say let reindeer equals paces dot map, and we're going to create a reindeer dot init. Ooh, I don't actually have an initializer here, so we're going to init, and it's going to do pace reindeer speed. Okay, self.pace equals pace. So now I can map. We're going to do reindeer pace.map. Each one of these paces is going to be mapped into a reindeer initializer. So now we have a list of reindeer. Now from those reindeer, we want to get the let distances traveled equals paces dot. Actually, I want to make sure my test case is passed first before I start guessing. So we're going to do test case A, text, right? Expected output. So it's going to be a race, but I'm going to say for this test case, I want to make sure. Comment. Okay, so let's do this. We can do this. We're going to do a multi-line. We're going to go like this. I'm going to put both in here. Right, there we go. And the expected output is going to be 1120. And that is after 1,000 seconds. Now this says 2,503 seconds. So for this test, I'm going to have to do 1,000 seconds. Equals reindeer dot map r in return r dot distance traveled in 1,000. Just for the test case, we're going to do distance traveled in 1,000. I'll have to remember that if this test case passes and it tries to run the actual puzzle, that puzzle output is not going to be valid because it's not the right number of seconds. Okay. Comment would win if the race ended at 1,000 seconds. Okay. Reindeer.map, distance traveled, and then we have to find we're going to do let fastest distance, longest distance equals distances traveled dot sorted. What do you mean sorted by? These should be numbers. Should be integers. Cannot type. Oh, did this? Oh, I see. I forgot to return int. Duh. Okay. Yep, longest distance dot sorted dot last. So the highest one here is going to be the longest distance. All right, we're going to return longest distance. So the expected output here is going to be 1120 because we're doing it in 1,000 seconds. Let's see if that's what we get. Okay, PB paste, advent of code. We are on 14. And make sure I have my puzzle input on my clipboard. Copy. All right, here we go. Okay, what's going on? Not seeing any messages about compiling. Oh, here we go. Planning build. Okay, compile complete. Okay, that was so the test case is passed. So now I need to go back and update my distance traveled. So I'm going to go ahead and I'm going to go like this. I'm going to comment that out, and I'm going to do distance traveled in, what was the number? 2503. Okay. So now we're going to try it. So now this should give me the correct answer. 2640. Haha, that is the right answer. You're one gold star closer to powering the weathering machine. Now, before I go to continue part 2, I'm going to make a guess. I'm going to guess that the next puzzle is going to be which reindeer or what is the number. So it's going to be a race to see how the distance. It's going to be how long it takes to get to a certain distance. And you're going to have to find out how long it takes for the fastest reindeer to get a certain distance. Okay, part 2. Seeing how reindeer move in bursts, Santa does he's not pleased with the old scoring system. Instead, at the end of each second, he awards 1 point to the reindeer currently in the lead. If there are multiple reindeer tied for the lead, they each get 1 point. Okay, this is very interesting. He keeps a traditional 2,503 second time limit, of course, as doing otherwise would be entirely ridiculous. Okay. Given the example reindeer from above, after the first second, Dancer is in the lead and gets 1 point. He stays in the lead until several seconds into the Comet's second burst after the 140th second. Comet pulls into the lead and gets his first point. Of course, since Dancer has been in the lead for 139 seconds before that, he has accumulated 139 points by the 140th second. After the 1000th second, Dancer has accumulated 689 points, while poor Comet, our old champion, only has 312. So, with the new scoring system, Dancer would win if the race ended at 1,000 seconds. Again, given the descriptions of each reindeer you're in your puzzle input, after exactly 2,503 seconds, how many points does the winning reindeer have? So I was completely wrong. I did not see that coming. So now we're going to score points. Okay, so now we need a class to represent the race. And then within the race are going to be multiple reindeer. And we have to, we're going to have to see who's in the lead at each given second. Yes, perfect. So we don't have to do this step-by-step thing. We can just go for each second in the race, find out which reindeer are in the lead or which ones are tied for the lead, which ones have traveled the furthest distance, and then give 1 point to each reindeer. Perfect. Okay, so we even have our reindeer names all ready to go for us. We're going to do race. We're going to do var reindeer is going to be the plural form of reindeer is just reindeer, right? It's not a different word. I think that's true. Yeah, okay. And then reindeer and funk fastest. No, most points. Yeah, most points after seconds. Okay, so this is going to be the thing that we return at the end. So to do this, we need to go for, so we need to have a scorekeeper. Score. And this is going to be a string integer. Ooh, no, actually I want to use frequency. So I have a nice little data structure called frequency, which takes a key, which is a hashable object. In this case, we'll probably just use reindeer name. And it starts at 0, and it has utility functions to increase or decrease those numbers. So, excuse me. Let's scorecard equals frequency string, and the key of this frequency is going to be the reindeer name. So, and the good thing is that the frequency struct will default every name. If it's a new name, it'll default to 0. So you can increment on names that have not been added to the frequency data structure yet, which is actually really convenient. So you don't have to check for null every time you access a key. Okay, so we have our scorecard. So then for s in 0 ... less than seconds. No, actually 1 ... seconds. So because second 0 is not going to be anything. They're not going to move. Okay, where's mine? There we go. ... seconds. So we're going to start at second 1, and then if we're doing 1,000 seconds, then we're going to end at second 1,000. So we're going to do S, and then we're going to do for each reindeer, let, we want to find the maximum. No, wait, if there's a tie, so we need to, okay, so here's what we're going to do. We're going to do speeds, var, no, let distances equals frequency, string, and this is going to be another one. So this one's just going to be thrown away at the end of each loop and rebuilt. So distances, no, this should be a var. So then for, no, reindeer dot for each reindeer. That's going to be confusing. I'm just going to call it R for reindeer. And we're going to do distances for R dot name equals R dot distance traveled in S, right? And then we're going to take that, we're going to find the maximum. We're going to find which ones, that's it, that's all I have to do. And then from distances, now that we have this, we're going to find most frequent. So here's the problem. Shoot. Can I do values where, no. Increment members of, unique values, most frequent. Unique values. Oh, I see. So this is going, that's not, yeah. So I want unique values. So the weird thing about this frequency is that it's under the hood, it's modeled as key. It's a dictionary key with value, but you can also enumerate it because it's a frequency. It's designed for, like, you have a bag of marbles and you have 3 white marbles and 4 black marbles. So instead of doing, white, black, you can just have white 3, black 4. And then if you want to do values, it'll fan them out. So then you can, like, enumerate over each one. But that's not what we want for this one. That's kind of a useful tool for a different kind of puzzle. But for this one, we just want, for all of the unique values, we're going to do map. And we're going to do reindeer name. So name in. And, oh, shoot. See, now I'm puzzled because I need to, if it's a tie, I need to know what the tie is. Can I just do a distances.map? .map? No, I can only do unique values .flat map, unique values, okay. Unique values .map, okay, name. So the name of each, oh, shoot. Maybe this is wrong. I think this is not what I wanted. Frequency was not the right choice for this. I'm going to change my mind. It's actually going to be a plain old dictionary. String int. Okay. How is that? Oh, because I have to initialize it. There we go. Okay, so now distances. I can map this and I get a key and a value. Okay. Shoot. If I distances, what if I sort it? Sorted by, sorted by, key 1, value 1, key, oh no, pair 1, pair 2. So we're going to return pair 1 dot value is less than pair 2 dot value, right? I think that's what I want. It's unused, okay. So is there a description? Is this going to tell me, okay, returns the elements of the sequence given, do I return, calling the related sorted method, are in increasing order. Okay, oh yeah, what is the name of that? The predicate name is are in increasing order. Okay, so this should actually be like this. So if pair 1 dot value is greater than pair 2 dot value. So we're going to do highest score, let highest, H-E, okay, let ranked reindeer, highest score equals ranked reindeer dot last dot value, which is going to be the highest score. And then we're going to do filter. We're going to do highest scoring reindeer equals ranked ranked reindeer dot filter is included Key name score. No, name distance. Highest distance. This should be highest distance, not highest score. Distance. Furthest reindeer. Furthest reindeer. And then we're going to return distance is, no, it should be singular. Distance. Distance equals highest distance. Okay, so this will return all of the reindeer that are of the highest distance. So then for each one of these things, we need to scorecard. And then furthest reindeer. Furthest reindeer for each. We're going to, we have name, distance. I don't need the distance in this case. In fact, I don't even need the name in this case. I'm going to give it an underscore to indicate that that's not important for that particular operation. Okay, and we're going to do scorecard dot increment name. Let constant. Oh, okay. Well, that was my bad. Okay. Has no initializers. Oh, of course. Init reindeer. Reindeer. Self.reindeer equals reindeer. For S in all the seconds. For each second, we have distances. Oh shoot. Maybe I should have extracted this to a separate function. That probably would have been the right move. That's okay. I think it's fine the way it is. I think it'll solve the puzzle. Scorecard increment, and then at the end of this loop, we go to return scorecard dot highest dot most frequent. No, that's going to return a string, right? So return scorecard most frequent. There we go. Right? Excuse me. Okay, so now my race. So the same, I'm going to copy and paste this. Test cases B. So for my race, again, at 1,000 seconds, the expected output will be, after 1,000 seconds, Dancer has accumulated 689. Okay, and then solve B. We are going to do, so we need all the reindeer. You need to get those reindeer out of here. And then from there, we need to do let race equals race reindeer. And then return race dot most points after. In this, for the test, we're going to do 1,000 to make sure that it passes. But for the real puzzle, we'll have to update that to, what was it? 2,503 seconds. Okay. So with that, we're going to go ahead and run the puzzle. Solve B. Okay. So the test cases pass, which means we can comment them out. Change my seconds to 2503. And let's run them again and get our answer. Here we go. 2,336. Submit. Oh, no. Not the right answer. Your answer is too high. If you're stuck, make sure you're using the full input data. You guessed 2336. What am I doing wrong? I got my test cases passed. 2503. Oh no. This is bad. I don't know what to do. Oh no. Okay. So I have a hunch that it has something to do with this little edge case where if there's a tie. Given the example reindeer, he stays in the lead until several seconds after. Worth 1 point to the reindeer currently in the lead. If there are multiple reindeer tied for the lead, they each get 1 point. He keeps the traditional 2,503 second time limit. Okay, so... Oh, damn it. Okay. Answer is too high. Okay, I mean, it's not... There are not very many options. I don't want to brute force the puzzle because that would be cheating. How is that too high, though? Okay, so let's... Here's what I want to do. If furthest reindeer dot count is greater than 1, then we're going to return... No, we're going to print tied for the lead, and we're going to do let names equals furthest reindeer dot map key, and then dot joined with a comma. And then we're going to tied for the lead, and I'm going to go ahead and put that here, names. Okay, let's run this. And then, so just to make sure that they both get points, then I'm going to do tie for the lead, Prancer, Blitzen, and we're going to say furthest reindeer. We're going to do furthest reindeer dot for each, name, distance. We're going to do print name, and then that reindeer's distance, in parentheses, and then we're going to do the score for that reindeer, scorecard, for name. Okay. And then after, we're going to do if furthest reindeer dot count, because we want to make sure that they both got points. Okay, tied for the lead, Blitzen and Prancer. Okay, Blitzen 252, Prancer 252. Blitzen has 69, Prancer has 56. Scoring, Blitzen 252 now has 70. Prancer now has 57. Okay, Blitzen, Prancer 70, 57, 71, 58. Tied for the lead. Scoring. Okay. Two, 3, 3, 6. That's what I answered last time, right? Yeah. Make sure you're using the full input data. There are also some general tips on the About page. You can ask for hints on the subreddit. Please wait 1 minute before trying again. Shoot. Two, 3, 3, 6 is not correct. I'm going to make a note of that. 2, 3, 3, 6 is not correct. Could it be... I wonder if it's this. That doesn't seem right. Start at second 1 and then go number of seconds. Let's see if I get a different answer if I do this. I probably will. 2, 3, 3, 5. Right, because there's 1 less second. Okay, what if it's 0 to number of seconds? 2, 3. I'm going to try 2335. 2335. I mean, I got to be close. Answer is still too high. I don't want to just like start going down. I'll say too high. Too high. So I think I was actually correct the first time. So it's 1, 2, ... seconds. I mean, this would be 2337, I'm sure. Yeah, and there's no way that's correct. Let's double check that I'm using the correct number of seconds. 2503. Yeah. Reindeer distances sorted. Let's just make sure that I am getting the, I'm scoring the correct. So okay, so at the beginning I'm going to do, can I do print scorecard? Yeah, okay. I'm gonna print the scorecard. I'm gonna comment this out because I feel like this is working correctly. The thing I'm worried about is for this reindeer. So we're gonna do prints. We're gonna print the scorecard. Here's what we're gonna do. We're gonna, for each thing, we're gonna print the scorecard, and then we're going to print distances, and we're going to print scoring, and then print the scorecard again. I'll move this up here. Scorecard, distances, scoring, and then we print the scorecard result. Okay, well, I'll print a divider to make it easier to read. Okay. Okay, so we have counts. Prancer, okay, so this is the initial scorecard. Prancer has 63 points, Vixen has 10, Rudolph has 18, Cupid has 19, Comet has 21, Dasher has 2332, Blitzen has 73. So then distances, Comet has, so Dasher would be the one in the lead, according to this. So let's make sure Dasher 23,000. No, that's wrong. Dasher is in last place. Boo. Oh, well, that explains it. I'm giving points to the people in last. So this is backwards. That is backwards. Of course, in ascending order, in increasing order, that means pair 1 would have to be smaller than pair 2. I'm so dumb. All right, now we're going to try it again. We're going to make sure that my test cases pass. Here's what I'm going to do. My solve B, I'm going to do if reindeer.count equals 2, that's going to be 1,000, otherwise 2503. That way I don't have to keep going back and forth. My test input has 2 reindeer, that's it. Okay, and make sure 2503 is the correct. Okay, here we go. Come on. Okay, now it says 1102. This is much smaller than my previous input. Let's see if this works. Yes! That is the right answer. Okay, see? is my freaking sorting function. I was sorting it backwards instead of forwards. Oh, I feel so foolish. 1 gold star to powering a weathering machine. I am astonished. That is, well, no, that's interesting. Because in a 2 reindeer race, one of the reindeer is in first place and the other is in last place. So, of course, the test case is still passed. Because even, it wasn't asking which reindeer won. It was asking which reindeer had the most points. So, if it was a tie, they'd both get points. If one was in the lead, one would get points and the other wouldn't. So, in the test case, it didn't matter whether it was forward or backward, whether I was scoring the first place reindeer or the last place reindeer, because the outcome would, the highest points would have been the same. It just would have been the opposite reindeer. So that is why the test case is passed and that's very, very interesting. So, okay, good. I'm going to go ahead and clean up my code here. Okay. I don't need this output. Okay, let's do that. And one final thing I'm going to do is I'm going to take this same pattern here, reindeer.count. Here we go. So then I can uncomment this test case, which means I can run it, and it should still pass, and then I'll get the correct answer. Yes. So if I go back, 2640, yep, 1102, yep, okay, good. All right, that's it for day 14. Thanks for hanging in there with me. That was a journey. All right, solve 2015, day 14. Commit one file. Whoo! All right, day 15 is coming up next. I will see you then.